This is practice A for section 2.6. We're going to look at numbers 11 and 12. We're going to use the given information in this diagram to prove this statement. Here's what you're given, and I know this is a little bit tough to read the first time through, but this is 2 times the measure of angle ABC. It's not 2m, it's 2 times the measure of angle ABC equals the measure of angle ABD. That's what you're allowed to use. So what that means is make up a number for the measure of angle ABC. I'm going to say it's 50. Well, if I multiply that by 2, I get 100. So what they're telling you is the measure of the big angle is, this is the whole thing now, 100 degrees. That's what you're allowed to use. Now, if you know that's 50 and the whole thing's 100, what does that mean about this guy? I think you already know that means that has to be 50 as well. Well, if that's 50 and that's 50, doesn't that show that these two angles are the same? Okay, now you need to prove that, and this, I think, is probably the first time that you're actually alone on your own to do this. So, first statement is writing down your given. 2 times the measure of angle ABC equals the measure of angle ABD. That's given. Now, you know this is true, but to actually do it with the geometry, not the numbers, that's a little bit more challenging. Right, so hopefully you could have got a couple of these steps, or at the very least are able to follow this as we go through. If we have 2 angle ABCs that equal this angle, I can rewrite that like this. The measure of angle ABC plus another measure of angle ABC equals measure of angle ABD. All I'm doing is separating this. 2 times this is the same thing as that plus that. So basically, I'm just going to put simplify here. I kind of reorganized my information. That's all I did. The next thing I'm going to do is I'm going to look at the diagram, and I'm going to notice that I have 2 little angles that make a big angle. Now, one little angle is a measure of angle ABC, so I'm going to write that down. Now, I could have also named this angle CBA, but that's not going to help me because I've already named it angle ABC over here. So try to stay consistent with how we have things named. The other angle is angle CBD, and I notice if you look in your proof, they're calling it angle CBD as well, so don't call it angle DBC. Those 2 little angles make the big angle, angle ABD. Two little angles make a big angle. That's angle addition postulate. Now, you have the information right now to kind of go at this thing. You just need to recognize that we have this thing and this thing, and they both equal this thing. If you have 2 things that equal the same thing, what do you know about these 2 things? They're going to be the same as each other. So the measure of angle ABC plus the measure of angle ABC equals, all I did was write this. That thing needs to equal, I'm going to try to underline this with a straight line. It needs to equal that thing. That's the transitive property. We have 2 different things that equal the same thing. Now take a second and look to see what you have, because from here we're going to get one step closer to this. Notice how they both have the measure of angle ABC on each side of the equation. Well, if you took that away, you'd be left with one measure of angle ABC equaling the measure of angle CBD, which is what we wanted to show. We wanted to show these 2 angles were the same, and we just did it. We subtracted the same thing from both sides of the equation. That's your subtraction property of equality. Now we have two equal angle measures. What does that mean about the angles? They're congruent angles. So angle ABC is congruent to angle CBD. That's definition of congruent. Okay, now that's the first time you were actually responsible for doing all of this on your own, and I'm sure it's a lot to do first. I'd be shocked if any of us got all of this first time through. This takes a long time to develop these skills. But hopefully the logic makes sense as you move through. And the more you see it, the better you get. Okay, here's number 12. You're going to take part in a 3-day bicycle tour. On the first day, you ride 95 miles. On the third and final day, you also ride 95 miles. Use the following steps to prove that the distance you ride in the first 2 days is equal to the distance you ride in the last 2 days. Part A says draw a diagram for the situation using the line segment to represent the total distance of the 3 days and dividing the line segment into 3 parts that represent the daily distances. Okay, so this should look familiar to you. We did a problem in class with a shopping mall that was exactly like this. They're telling you these distances are the same. Now, if these distances are equal, doesn't that mean A to C equals B to D? So we know those are 95. Let's just say, I don't know, to keep it simple, I know it doesn't look like it's to scale, but let's say B to C is 100. Let's say you did 100 miles in the middle. A to C is 195. B to D is also 195. They're equal. State what is given. Segment AB is congruent to segment CD. That's what's given. What do you need to prove? You need to prove that segment AC is congruent to segment BD. Part C says write a 2-column proof for that. Well, I'm not sure. I guess I'm going to do it here. We've got statements and reasons. That's what we're given. We know this segment is congruent to itself. That's the reflexive property. So that you can fit that into your proof if you like. Distance from A to B. Try to keep the picture in the screen there. Plus distance from B to C equals a distance from A to C. I'm also going to do this. Distance from C to D plus distance from B to C equals distance from B to D. That's your segment addition postulate. Now, we probably should have stated this a little bit earlier, but notice how we're dealing with congruent segments here and now segment lengths. I could have stated this up here. It's not wrong if I state it down here. I know these two lengths are equal. That's definition of congruence. Now, if these two things are equal, I can substitute them. So I can come up here and I can take this thing out and replace it with this thing. So in my step 5, that's what I'm going to do. I'm going to rewrite this same line. Except what I'm doing is I'm taking this out and putting this in. That's substitution. Now, hopefully you realize that this thing and this thing are the same thing, and they equal two different things. So what does that mean about those two different things? Don't put that segment there. That's distance from A to C equals distance from B to D. That's your transitive property. Now remember what we're trying to prove. We're trying to show these two segments are congruent. I just showed their lengths are equal. That's definition of congruence. Okay, so you can pause this if you need to take a look at that.